All right, welcome back now to episode 5 of Algebra. We have some questions there looking at us. We have A raised to power 1 over 2, B raised to power 2, C raised to power minus 2 times is multiplying. So times A raised to power 1 over 6, B raised to power 1 over 2, C. So how do I deal with multiplication? Number one, we will have if I have a raised to power 2 times a raised to power 3, I'm sure you know that this is 2 of the a's there. This is 3 of the a's there. When I add them, they will join together and become a raised to power 5. So it's simply the index 2 plus 3. So multiplication is addition of the index, just as division is subtraction of the index. So we have a raised to power 1 over 2. The other a raised to power 1 over 6 there becomes plus 1 over 6. Then b raised to power 2 plus the other power of b there is 1 over 2. Why are we adding? Take note, because they are multiplying. Then c raised to power minus 2 plus the other c there is power 1. Is power 1. So 1 over 2 plus 1 over 6. Very quickly do that, and 2 divided 6 is 3. 3 times 1 is 3 plus 6 divided 6 is 1. 1 times 1 is 1. That gives me 4 over 6, which is 2 over 3. So this is a raised to power 2 over 3. B raised to power 2 plus half is 2 and a half. Then c raised to power minus 2 plus 1 is minus 1. Your answer can also be, this 2 and a half can be 5 over 2 c raised to power minus 1. That will be your result. Please take note, whenever you are multiplying, you are adding the powers. Then we're going to division now. M n square raised to power 3 all over m raised to power half n raised to power 1 over 4, everything raised to power 4. Take note, the guy in the bracket, it is everything that is raised to power 3. If I said m raised to power 3, n raised to power 2 is different from this. This is simply saying this m is raised to power 3. This n raised to power 2 is raised to power 3. So this gives me m raised to power 3, then n raised to power 2 is raised to power 3. So n raised to power 2 is going to be in 3 places. So n raised to power 2, n raised to power 2, n raised to power 2. Of course, if they are in 3 places, it gives you what? N raised to power 6. It's just simply doing the 2 times the 3, 2 in 3 places, over m raised to power half raised to power 4. So it's simply the same thing as doing what? Half times 4. Half times 4, which will give me 2. So m raised to power half, everything raised to power 4 is m raised to power 2. The n raised to power 1 over 4 raised to power 4 is what? 1 over 4 times 4, which gives me 1. N raised to power 1. So with that being said, take note, when you have a power and it also has another power, you multiply the powers. But when you are multiplying the algebra by another algebra, you add the power. But if it is the algebra having a power and that same algebra has another power, then multiply the power. So m raised to power 2 will divide one of the m there to remain m. N raised to power 1 divide one of the n there to remain n raised to power 5. So that is your answer for question 2. Now to question 3. Question 3 is a little bit wide. The numerator, they are multiplying themselves. To open it up, I'm going to rewrite them now. X raised to power 2, y raised to power half. You notice there you have square root of x. Square root of x is the same thing as x raised to power half. Take notes. 9 raised to power half is square root of 9. You're asking me how is it possible? How is that so? That is how it is. If I go further to explain fractional index law of indices, you notice that the denominator is the nth root. So second root of 9 is square root. Then x raised to power, you see this is cube root of y raised to power 2. So the root is 3. That will be your denominator, 3. Then your power is 2. So the y is raised to power 2, but it has a cube root of 3. So this is how we write that. Then for the denominator, this is x raised to power 5, y raised to power 3. Everything is multiplying, is raised to power half. So which is first 5 times half gives you 5 over 2. Then y raised to power 3 times half gives you 3 over 2. To solve this, how do we go about it? We need to resolve the numerator first. Numerator, they are multiplying themselves, so we resolve the numerator first. How do we resolve the numerator? How do we resolve the numerator? We are going to add the index of the numerator. So this is 2. The index of x is 2. The index of x is half. Since they are multiplying, you add their index, 2 plus half. So it gives you x raised to power 2 plus half. The other one, y raised to power half plus 2 over 3 over x raised to power 5 over 2 y raised to power 3 over 2. Going on further, we have, let's add 2 plus half gives me 2 and a half. 2 and a half is 5 over 2. Then half plus 2 over 3 gives me half plus 2 over 3 now. Let's clear this space so we can solve at ease. Half plus 2 over 3, that's half plus 2 over 3. 3 and 2, the LCM is 6. 2 divided 6 is 3. 3 times 1 is 3. Plus 3 divided 6 is 2. 2 times 2 is what? 4. 3 plus 4 is 7 over 6. So that will give me 7 over 6 there. Divided by x raised to power 5 over 2. Y raised to power 3 over 2. If you observe closely, the powers of x, they are the same. So they can divide themselves. They are gone. So what I have now is y raised to power 7 over 6 divided by y raised to power 3 over 2. Remember we said when they are dividing themselves, you subtract the index. So now we're going to do 7 over 6 minus 3 over 2. 7 over 6 minus 3 over 2. LCM of 6 and 2 is 6. 6 divided 6 is 1. 1 times 7 is 7. Minus 2 divided 6 is 3. 3 times 3 is 9. So 7 minus 9 is minus 2 over 6. And after which 2 can still divide. You have minus 1 over 3. Because 2 divided 2 is 1. 2 divided 6 is 3. So y raised to power minus 1 over 3. That is your answer for question number 3. Going on further to question number 4. Question number 4 says a raised to power 3, then square root of b, then square root of c raised to power 5. So I'm going to try to rearrange them. You can either decide to solve this first. When you finish solving it, then you now put your values of a, b, and c. I think that's what I would do. Or you put the values at once. When you finish solving it, you now multiply the two brackets. But I think I'll do the two method. So for question number 4, let's watch out for the next episode so that we can have time to deal with the two methods.